This video will describe table spellout rules, and you can use a table spellout rule whenever you have a set of affixes and they're all accomplishing the same thing. For example, suppose all of your nouns are marked for number or marked for gender. Over here, just for this example, we've marked our nouns for gender. So I've added a feature called gender. John is masculine, Mary is feminine, etc. And let's say, just for an example, that we need a morpheme, let's say a prefix, on every noun to indicate its gender. So we can write a table spellout rule for that. We'll do this for nouns. Add the gender affixes. So this will be a table spellout rule, and we'll make this a prefix for now. It'll begin with the current entry, the layer's name. These tables can have up to 50 layers, and each layer needs a name. We'll call this layer gender, and let's create a column for each gender. And we always need a name. The default is general form. Let's call this masculine. We can click here, and it will copy the name of this feature to the name cell, and then we select masculine. And let's enter, our prefix will be mask, masculine. And let's add another column. We'll call this one feminine. The name is empty right now. We click here, and the name of this feature is copied there. Select there, and we'll say our prefix is feminine. And one more, we'll call it neuter, and select there. This prefix will be neut. Okay, that's good for now. Let's double click here and enter a name, gender. So now when we run this, we see that there's a prefix. If we say show morphemes, there's a prefix labeled as gender. John gets marked with mask, Mary gets marked with fem, etc. We can change this from a prefix to a suffix. Everything else stays the same. Now it'll be a suffix. We see all the suffixes. We can also change it to an infix. Let's put it after the second character from the beginning of the word. So now we see the first two characters and then the infix. We can also change this. If we say new translation, okay, that doesn't make sense, but we'll do it. The new translation means this mask will now be to replace the translation of John, just so you can see. Mask, fem, mask. So that doesn't make sense. But someday you may need it. If we say add word, now these will be separate words. And when we do this, so now we're adding a word, we're adding it to noun, so our noun phrase structure rule, we'll get this message. You've just entered a new constituent into noun phrases called gender. Do you want to edit your first noun phrase structure rule? I'm going to say no. We'll say initialize, generate. So now we have these new words. They're separate words. They're put at the end because, as you can see, they're inserted at end by phrase structure rule. The phrase structure rule didn't know where to put them, so it puts them at the end. Let's change these to one more option, to a circumfix. Now for a circumfix, we need to have a prefix and a suffix. Let's say the suffix is XYZ. For feminine, it's ABC. And for neuter, it'll be IJK. So if we run these now, now we'll have a circumfix. mask John XYZ, fem Mary ABC, etc. You can have up to, I think it's 50 columns and 20 rows, and up to, I believe it's 50 layers. So more than enough, more than anyone should ever need. But again, you use these whenever you have a set of morphemes, and they're all accomplishing the same function, so you can group them together. Another option is to have 3 separate simple spellout rules. One simple spellout rule adds the masculine circumfix in this case, another simple spellout rule adds the feminine circumfix, and another adds the neuter circumfix. But when they're all combining the same function, and you want them to have the same tags, you can combine them into a table. When you do have multiple layers, you can also click up here and specify, let's say this layer only applies to singular nouns. And then we can say add layer, and this layer will only apply to plural nouns. So you can specify a feature value up here in the upper left corner. We're not going to keep this layer, so I'm going to say delete layer. So you can specify a value up in the upper left corner, and then before that layer is checked, that upper left corner will be checked. And if that corner doesn't match the word that's being translated, then this rule will go to the next layer. As always, these layers are executed from the back towards the front. So you can put features up in the upper left corner, and then it'll check that feature first, and then if that feature matches the word that's being translated, then it will come and check if the row has features. You can also specify features for the rows. Just for example, first mention. Then we could add another row that's routine, participant tracking, etc. So when this upper left corner matches, then the software will check to see if the features for the row match. If those features match, then it will start checking to see which column features match. And the rule will save the cell, the last one in the table that matches. So if multiple cells match, it will be the last one in that layer that matches. I just checked the software, and Table Spellout Rules, for example, here's one used for pronouns. Table Spellout Rules can have up to 99 layers. They can have up to 50 columns per layer and 20 rows per layer. And I'd like to comment a bit more about how these rules are executed. When it's time to execute this particular rule, it will start with the back layer. And the first thing it will do is check the upper left corner. So here, in the upper left corner, we see that it has to be a noun with a surface realization value of relative pronoun. Well, let's say the noun that's being translated in the verse at the time it doesn't have a surface realization value of relative pronoun. So it won't even check the rows or the columns. It'll go to the preceding layer. So let's say the noun being translated doesn't have a surface realization value of locative pronoun. So it'll go to the previous layer. Let's say the noun isn't a possessive pronoun. It'll go to the previous layer. And it'll keep going until it finds a layer that matches. So let's say the noun being translated does have a surface realization value of reflexive pronoun. Then the software will check the first row. Let's say it doesn't have a person value of first. Then it will go to the next row. Let's say it doesn't have a person value of second. It'll go to the next row. Let's say it does have a person value of third, but the gender isn't masculine. Then it will go to the next row. Let's say the noun being translated does have a person value of third and a person value of feminine. So the features for this row match. Now it will start checking each column in this row. So if the number is singular for the noun being translated, then the software will remember this cell. It won't use it yet, but it will remember the cell because this cell matches. Then it will continue checking additional columns in this row. It will check all the columns, however many there might be. Then it will continue checking the additional rows if there are more. And the software will remember the last cell in this layer where everything matches, the rows, the row matches, and the column matches. And whichever cell is the last cell in the layer that matches, that cell will be used to modify the current word that's being translated. So it starts at the back, works its way forward, and when it finds a layer that matches, it'll check all the rows and all the columns. If none of them match, then it will continue going to an earlier layer. But if one of them matches, if even one cell in a layer matches, then the software won't go to earlier layers. It will remember the last cell in that layer where everything matches.